we are going to talk about differentiation of Laplace transforms, or we call it the multiplication by power of t property. So if Laplace of f of t is equal to f of s, then it follows that the Laplace of t raised to n times f of t equals negative 1 raised to n times the nth derivative of f of s. So again, f of s is the Laplace transform of f of t. So please take note of this theorem. Now, of course, you might be asking how it became negative 1 raised to negative n, or the presence of differentiation in this equation. So take note that if we are going to utilize this notation, f raised to n, so this means that nth derivative, okay, it may be prime, double prime, triple prime, okay, it means that it's a differentiation, okay, of f of s, or the Laplace of f of t. Again, we are differentiating the transform and not the f of t. So you first get the transform and then differentiate. And take note that n is equal to 1, 2, 3, and so on. So there's no negative, or if it happens that you will see negative n, it will not be possible to use differentiation to solve the transform of that given function. So there is another way to solve it. So let me just give you the proof, or show you the proof to why it became negative 1 raised to n. So firstly, let me write, or let me present to you f of s equal to the integral of e raised to negative st times f of t dt with limits from 0 to positive infinity. So this again is the definition of Laplace transform. What we will do is, if we take the derivative with respect to s of this equation, so we differentiate this one using the Leibniz rule for differentiating under the integral symbol, so we can actually interchange the positions of the operation here. So we can put the integral symbol before the differentiation technique. So that's one possible rule for dealing with this kind of function or representation in calculus. What we did here is we put the differentiation inside the integral symbol, or nasa integrand na siya. Since you are to differentiate with respect to s, the function of t is held constant. E raised to minus st is the only function that has s in it. So you will only be differentiating this e raised to minus st. So you put this f of t before, or you just copy it since it's a constant. It's held constant. So the derivative of e raised to minus st is, you just copy this, e raised to minus st, and then differentiate minus st with respect to s. So t will be constant, so you just copy minus t times e raised to minus st times f of t dt is the resulting integrand here. As you know, there's still the kernel function, so it means it's still under the integral symbol with limits from 0 to positive infinity, so it's still the definition of Laplace transform. So you can actually put negative sign before the integral symbol, and that noticing here in the integrand, you have the kernel, and then you have the function f of t times t. So you can write this in the notation that we use, the operator, so Laplace of f of t times t. You have a negative sign before the operator. Here showing you, if we take the Laplace of t f of t, so multiplying both sides by negative, nasa right side na yung negative sign. So you can actually do that, or divide both sides by negative. Either way, multiply or divide by negative 1 to make this operator positive. So the presence of t there means that you are to differentiate the Laplace transform, but you have a negative factor in it. If we are to differentiate again this equation, so for the second time, this is how we write. So second differentiation of f of s. So we differentiate again this one. It means that, copying this, so you have the same derivative or the same function to differentiate, and that is e raised to minus st, because that's the only function that has s in it. The derivative of this is negative t times e raised to negative st times f of t. So, ibig sabihin may negative t ulit. So, you multiply negative t by negative t. So, it will become positive. So, this becomes positive t squared. So, Laplace of t squared times f of t. Okay, so what I did here, I did not put anymore the differentiation since I have done differentiating or introduced ko na yung negative t. Now, for the third time, differentiate mo siya ulit. Kasi may gusto kong patunayan. We have to prove something na tama yung formula. You have to multiply again with negative t. Okay, or you can write this one in terms of the definition. So it is to minus st and t squared f of t. So 0 to positive infinity. Ito, function of t, and held constant. So just copy this one, then differentiate this one. So it's negative t times e raised to minus st. So my negative t also multiplied to t squared, it will become negative t cubed na. So Laplace of t cubed f of t. So what have you noticed? For first differentiation of the Laplace transform, it became negative, right? May negative factor ka. And then for the second time, it became positive, but you have t squared now. For the third time, negative again. If you try to differentiate again for the fourth time, it will become, so multiplied by negative t, it will become positive t raised to 4. So it's alternating yung factor. Negative, positive, negative, positive. So it means that we have, for the nth derivative of the transform, Laplace transform, so we have a negative 1 here raised to n. Okay, if n is 1, so it's odd, right? We have a factor negative 1. Okay, if n is 2, positive. Negative 1 raised to 2 is positive 1. If n is 3, so negative 1 raised to 3 is still negative. So we have this.
It's just right to
Put negative 1 raised to n in this equation times the Laplace of t raised to n times f of t. Okay, now, since we are after, finding for the Laplace transform of function with, t inside the operator. So, okay, we rewrite. So, dividing both sides by negative 1 raised to n, or simply they're just equal. Negative 1 raised to n is equal to 1 over negative 1 raised to n. So, the Laplace of t raised to n times f of t is equal to, so you put 1 over negative 1, or simply negative 1 raised to n, nth derivative, okay, this is how you write, of f of s, okay? Or, if you don't want to put f of s, you can write, using the operator, Laplace of what? F of t, okay? So it means that before you differentiate, you are to take the Laplace transform of this f of t. Remember, n is equal to 1, 2, 3, and so on. Okay, let's solve. Let's apply now the theorem. Find the Laplace transform of f of t equals t times sine of t. If it is just sine of t, we will just have to use the formula directly, which is b over s squared plus b squared. The Laplace of sine of t is 1 over s squared plus 1. And because of t here, we need to differentiate this transform to obtain the Laplace of this given function t sine of t. Following this formula, so we have a negative factor, negative 1 raised to 1, so we have negative. Now you write the Laplace transform of f of t. So you have this symbol, d, it means to differentiate 1 over s squared plus 1. So using quotient rule, v times du, or the denominator times the derivative of the numerator, which is, for in this case, 0, yung derivative ng constant. Okay, minus 1, copy this one, times derivative of the denominator, 2s, all over the square of the denominator. So we have s squared plus 1 a quantity raised to 2. The next step is for us to, so there's no differentiation anymore, so you just have to simplify or to arrange our answer. So we have negative 2s multiplied by negative 1. We have positive 2s over the quantity s squared plus 1 raised to 2. So this is the Laplace transform of t times sine of t. Example number 2, find the Laplace transform of t times cosine of 3t. So remember, we have t in the given function, so it will undergo differentiation. So this is our guide. The theorem says that the Laplace of t raised to n times f of t is equal to negative 1 raised to n times the nth derivative of f of s, or the Laplace of f of t. So the Laplace of cosine 3t is s over s squared plus 9. Can say that the Laplace of t cosine of 3t is equal to negative 1 raised to 1, 1 because of the power of t is 1. And then first derivative lang of the Laplace transform s over s squared plus 9 na yung transform ni cosine of 3t. So using quotient rule to determine the derivative of this transform, so denominator first, yan, s squared plus 9 times the derivative of the numerator, which is 1 minus the numerator times the derivative of the denominator. So s squared, the derivative of that is 2s all over the square of the denominator. Combining like terms, so we have s squared minus 2s squared is negative s squared. Then we have plus 9. Then multiply it to negative 1. We have positive s squared minus 9 over the quantity s squared plus 9 raised to 2. This is now the final answer for the Laplace of t times cosine of 3t. Next, example number 3, find the Laplace transform of f of t equals t squared times cosine of 4t. So here we have the theorem, okay, negative 1 raised to n, where n is the power of t, okay, similar to the power of t here, times the nth derivative of f of s. So remember that the Laplace of cosine 4t is equal to s over s squared plus the square of 4, which is 16. Then, okay, applying the theorem, we have t squared. So it means that we have negative factor here, negative 1 raised to n. In this case, 2. Negative 1 raised to 2 is positive. And then we have second differentiation of s over s squared plus 16. Firstly, apply first differentiation. We still have differentiation operation here. We now differentiate using quotient rule, v du minus u dv over v squared. So s squared plus 16 is our v, or our denominator. Derivative of s is 1 minus s times derivative of v, our denominator, that is 2s, all over the square of the denominator. So before we differentiate again for the second time, let us first arrange or simplify this given function here. Okay, and finally, since it's simplified already, we can now apply differentiation. And once we do it, there's no more differentiation symbol or operation there. Denominator first, so s squared plus 16, quantity raised to 2 times derivative of the numerator, which is minus 2s, minus the numerator, which is 16 minus s squared. So you put a grouping symbol or parenthesis, and then differentiate the denominator, which is here. So using chain rule, so 2 times s squared plus 16 times derivative of s squared plus 16, which is 2s, all over the square of the denominator. So in this case, it will become raised to 4. Let's continue. We can see from here that we have s squared plus 16 in each term, s squared plus 16 squared, s squared plus 16 in here. So we can factor out s squared plus 16. So the idea of that is, since the denominator is s squared plus 16, we can cancel s squared plus 16, one of the s squared plus 16. We were able to have this result. The denominator becomes s squared plus 16 quantity raised to 3, because we were able to cancel 1 s squared plus 16 in the numerator. So we still have 1 here, s squared plus 16 multiplied by minus 2s. And then the second term, you have 16 minus s squared. Here we have 2 times 2s. The result is 4s. Okay, now distribute or expand this one, then combining like terms. So firstly, minus 2s times s squared is minus 2s cubed. 16 times minus 2s is minus 32s. 4s times negative 16 is minus 64s. Negative times negative positive s squared times 4s, we have 4s cubed. All over, we copy the denominator. So we combine like terms here in the numerator. So minus 2s cubed plus 4s cubed is positive 2s cubed minus 32s minus 64s, the same sign. So you just copy yung sign and then we add them. So 32 plus 64 is 96s. So this is our final answer, or you can factor 2s here. So we have 2s times the quantity s squared minus 48 all over s squared plus 16 raised to 3. Okay, that's the Laplace transform of t squared cosine of 40.